Hi, my name is Rodrigo. I'm going to explain how to disassemble malware on OllyGDB. I'm going to not explain everything about the stack because I don't know too much about the stack, but I'm going to tell you how you can get a general picture of what the malware is doing or what your code is doing. Okay, so the first is we have our Apache DNS server. This is going to make a fake network, and every request that is going to do the DNS is going to get by our Kali machine Linux. This one is running init so so every request is going to that address, So first of all, here well, we open a file. Sorry, I just eat enchiladas. So so the first thing is this is our on your C programs you have a global variables, okay? So this is our picture of the global variables. As you can see, when you get global variables, you make it with the D word, okay? You are like telling, hey, this D word, this is my global variable, okay? So what we are going to do here is create the heap and get the kernel get version and some other stuff before we get to our main function, okay? So below that we can see this function, okay? These args and our function. This is our main function at 0042 40 12 10, okay? So if I go to that address, this is our main function, okay? So the first thing is, what is the first call to in our function is this one, okay? 40 10 0 0, okay? So I'm going to add a breakpoint here, just a normal one. Also this is a Windows XP version. This is OllyGDB, so it's I think the the most updated the most updated version, but now is the 1.10. So I think it's one of the oldest version of OllyGDB. And so we run all malware, and it's going to stop in that call, okay? So here, yeah. So if I go to that call, we get this function now. So what is going this function? Is going to tell us that, hey, we are going to make a call to the internet get connected state, and if it is success, then we're going to print a internet connection success, and if not, there is no error, okay? So when you get this function 401271 is a function that stores the value, stores the buffer, and make a file or works with files, so in order to print this kind of strings, okay? So if you see a push and then a call, this is the argument. The arg is the push and the call is the function, okay? So here we are going to when the arg pass to that function is success internet connection, okay? So there is nothing new here. We are just seeing if our machine is going to have internet connection, okay? If we go through that function, let me add a breakpoint. I make a breakpoint after the calls because the calls also calls another function and another function, and there are nested functions. So we don't want to get into the details of that. This is not the purpose of the video. It's just to how you can work with OllyGDB and make and how how assembled language works. Okay. Also, a point to note is that every time a return function is called, the value returned is stored at EX. Okay, this register EAX X, like X-Men. X is for X-Men. No, no. EX is just stored 32 bits, 32 bytes. No, 32 bits. Okay. So after that, we get to the we call that function, and you can see when we get 1 is true and when we get 0 is false. So when we compare it, we're going to compare, and the the JE instruction tells us that if they are equal, we are going to jump to that address. Okay, so let's say that they are equal, that this value at EBP minus 4 is equal to 0. If we get that, we're going to get to that address. Okay, so the address at this point is going to be 004, and this is going to tell us that there is no internet connection. So how we can modify the values stored at EBP minus 4, we can tell that the EBP is a stack register. Okay, so we have, you can see on my right bottom pane that we have the value stored at 12FF6C, okay, and the value is 1. So if we want to modify, we click on modify and then put it 0, okay? But we don't want that, because if we do that, we are going to end the program, okay? So we don't want that. So instead of that, we tell A, we have internet connection, yes. And then we call this address is the stbuff and the ftbuff. Okay, this how do you say it? These functions are not named here because this is the oldest version of OllyGDB, and maybe some C function doesn't the software don't get that calls. Okay, that function. So we print it, and then we add 4. So here we're cleaning the stack from ourselves. Okay. Now after that we move 1 to EX. As you can see on my top right pane, we have the value change to EX to 001, and then this is we're going to jump to that address. Okay. And the address, what it's going to do is clean up the stack. The base pointer is going to go to the stack pointer, and we are done with this function. Okay. All right. And we return from our function. Okay. To our main function. Okay. Now, EX is going to get stored at EBP minus 4. In this case, EX is 1, and we're going to compare it. Okay. If that how do you say it? If also GNC or CETA, or how do you say it? I don't know. I just don't remember how to call that letter, but the pronunciation, I just forgot it. But it means that jump if not 0. Okay, so we're going to see. So imagine that. Well, not imagine. Our pointer in that address is 1. Okay, so we're going to make the jump. Okay. So, but what happens if our function is to 0? We are not going to make that jump. Instead, we're going to get to the XOR EX function instruction, and this is going to tell us that this is 0. and we are then after that we are going to we are going to go to the address 40.12.6d, and what is 6d is going to end the program. Okay, so we don't want that, so we need to make sure that this compare is not equal to 0, and it is not going to be, because as you can see our address is 1. Well, the value stored at that address is 1, so we are not going to end the program. Okay, then we are going to get to another call. Okay, 40 41 40 10 40. Okay, so we're going to that address. Okay, and that address, what it's going to do is also we're going to start our stack, and then we are going to push these args to this function. Okay, to the internet open 8. Okay, so what we're going to do is I'm going to make an internet connection, and this Internet Explorer, if you want to see what args are passed to that direction, to that function, you can go find in Google, you type the internet open function, and they are going to give you the args and what are they used for. Okay, and remember, this push is from right to left from your arguments. Okay, so this is the far right of your args in this function. Okay, and the first arg of the function is as Internet Explorer 7.5 PMA. This is the user agent. Okay, so we are going to start a connection. Okay, and we are going to request, and the URI that we're going to make that request is to http www.practicalmalwareanalysis.com and to cc.html. This is the file that we're going to read. Okay, and we're going to make a request to that file. Okay, to cc.html .html cc.html. Okay, so let's make this here. Also here we're going to make a breakpoint. We run it. Okay, so here we got that our stack and that value is 0c, so it's not equal to 0. Okay, if it is equal to 0, we're going to jump to the 40 10 9 90. Okay, and that is 40 10 90 here. We're going to load the effective address. Okay, to that how do you say it, uh, mm, so ex, yeah, so we're going to jump if it knows 0. Okay, so we are going to make that jump, but what it happens if it is equal to 0? We're going to push this, and also we are going to call the instructions of stbuff and ptbuff, and then we're going to close that connection. Okay, so that's what happened when this value is equal to 0. Okay, we are going to close our connection, and then after that we're going to jump to 4011 2c. So here for an 11 2c, it is also clean the stack and is going to end the function. Okay, so we don't want that, so we want to make sure that this value here stored at this address is not equal to 0. Okay, so then we are going to make the jump, and then we are going to load the effective address that is in this pointer to edx. So you can see at my top right pane how it's going to change the value of EDX. So the EDX is 14, 6, 8, and now it's going to change. We are going to store the address of that pointer on EDX. And now what we're going to do is we're going to push EDX that is stored at this pointer. We're going to load the effective address, and then after that we're going to tell I want to read well, it's not 200 bytes. I think it's how do you I think it's 512. Okay, 512. So we're going to load the effective address of the base pointer minus 210 to the EX, as you can see. And after that, we're going to push EX. Then we're going to move the base pointer, our base pointer, to 70. And then we're going to push ECX. And you would say, well, what the fuck we are doing here? Well, we're pushing all the args in order from right to left to read the internet read file. We're going to call this function with this arg: ECX, EAX, push EDX, and push the 512 bytes that we're going to read. Okay. And you would say, well, here we're storing here the pointer from our file to the end of our file. So you can see Lias is ending the first EX. The EX is going to store the last the last address of that string, and the dwip and this CCX is going to store the address of the first byte. And you would say, well, because we are going to read 500 bytes, that's why if we add it, we're going to get 10 plus 200. We're going to tell 210. Okay, so that's are the args passed to internet read file. So we call it, we move it. So we are at the breakpoint. And you can see EX is 1, so it's true. So we are not going to get that we read the file. If that's not the case, also you look to the jump not equal to 0, and if we don't make that jump, we are going to get the read file error. Okay. So after that, we compare it, we make the jump, and here, that's the interesting part. Here you can see it's going to read the first bytes. Okay. Here, as you can see on the address on SCP, here we had the HTML read bytes that read from the URL. Okay. So here ESP, here is you would see that ABP is our start address. Okay. Our start I mistake. EBP EX is going to get our start address, and ECX is going to get our finish address. Okay. So as you can see, we're going to move the pointer at EBP 2010 minus 210 to ECX, and ECX is 3C. Okay, ECX is 3C. So we are not going to make the jump. Okay, why? Because they are equal. So here, because they are equal, they are not going to. This is not going to make the jump. If we make the jump, as you can see, we are going to get to the address 11D. Okay, so this is not what we want. This is going to get our command. Okay, so what we're going to do is to move forward. The jump is not taken, as you can see. We are going to also move the pointer at 20 FFP, and you can see that the next byte is T, okay? No, it's H, but we're going to compare it to 21, okay? But if they're not equal, we're going to end the program. So we need to make that the EDX register has this X value 21, okay? So we're going to go to the EDX value, we're going to modify. I'm going to tell A, I want to this, okay? So yeah, and so the first thing is that, okay, because they are equal, we are not make the jump, okay? So we continue with our program, and we said like EAX has this 01. Now is going to have 74. Well, in X is going to be another one. I don't know, 74. So this one is a T, so you can see T. So we're going to exchange so we can get 2D. Now what happened? I don't know why. Let me see if I can search. I don't know why I cannot. I don't know what I'm going to do. So we're going to put 2D. And you can see that we're going to compare that. We're not make the jump. We continue. And now we read HTML, but we also don't want to make the jump, so we modify the value of XCX. And now put 2. So here the thing is, here is going to read the values of the minus sign, the greater than sign, our an exclamation mark, and two dash. If that's the case, then we're going to get our command. If that's not the case, if the string starts with HTML like here, we're going to get the error failed to get command. Okay. So after that, we are not make the jump. We move the. So what is the register AL? The AL is just, it takes just the 1 byte from the EX register. So you can see here that this instruction is going to store the bytes that are in the address EBP-20C. On the this byte is going to get stored on the EX register on the first byte. So you're going to see how the EX register change. So I told you. Then we're going to jump to the address pointed at that instruction, and then after that we're going to get clean all the stack. Okay. And then we're going to return to our main function. Okay. So after that, we're going to move the pointer at EBP -8 in this case 1 to our ex value. Okay, so here it is not equal. Test eax is going to compare to 0. If it is not equal, then I'm going to make the jump. If it is equal, then we are going to get to the x, then we're going to jump, and then this is going to also crash the program. So we don't want that. We need to make sure that eax doesn't store the value 0. Okay. So we move the base pointer -8 to the SEX, and also we pass the arc to this call. Okay, to this how do you say it, to this function. So what is this function does? Okay, so the function does here, the 004 is the ones who store the strings. It's going to start the buffer, and then it's going to make some this is going to be right to the file that is going to make is going to get printed on the command on the command line. Okay, so we move to our next instruction. When you get strings like ASCII success, the most I think what is going to come next after that instruction is going to some kind of print instruction, or store that string in another file or in another buffer. So you need to understand how you can analyze malware and not get into the details only if it's necessary. Here is not necessary. I don't think that this I don't know, maybe you are on a real world scenario, you need to check every part of the code. Okay, but if it is not necessary, you don't need to go to that. So if after that we clean up the stack, and then so here ex. What is ex? Ex is going to be the path of the malware, or where is stored the malware analysis. Okay, the path is this is our string. 3v8 is our where our string is stored. Then after that, we're going to store the last byte of the this instruction move CL byte pointer is going to store the last byte of or the first byte of this pointer into the first byte of the SEX. Okay, so here what you're going to see is how the SEX value is changed also. And now you're going to see that it's changed to this instruction. Okay, so then we're going to call our last function of the main program. Okay, so we're going to that call. When we call it here, it's very important to recognize statements of on the disassembler language. Okay, so first you can see we have 4 files. Okay, 4 files, 4 actions, well, 6 actions. Okay, so if you go through all the this is all the function. Okay, this is our function that we call from our main function. Okay, and if you see here at the end, we have a switch table. So you can see here that it's not an if statement. This how do you say it, a switch case, a switch code on the main function. Okay, so the variable, when you put switch parentheses your variable, the register that has that variable is the value ECX. Okay, so here's what is nice about knowing all of the registers, because every variable is stored on these registers, and these registers make everything easy. So we also create our stack, we move our stack, and then we tell A, the first byte of the string, we're going to move it to EX. Okay, and then that EX value, we're going to get, this is going to be stored at the pointer at the address of that pointer. Okay, so EBP minus 8, so it's going to store in this address. Okay, in this. Okay, so we're going to move that EX value to that. So if we move, we tell A, store that value on that address. Okay, and then we subtract that value. Okay, the value of C6 is L, and we subtract A. Okay, so this value is going to be stored at ECX. Okay, so when you make switch statements start from 0. Even if you have 5 cases, the assembly language subtracts 1, so it's going to be from 0 to 4 if you have 5 switch statements. Okay, so here the important thing is this one. Okay, this jump. Okay, so we are going to subtract 61 from the value of SEX, and we are going to tell that we're going to compare. So B is not less than 4. Okay, and the other instruction that is important to see is JA is going to tell us jump if it's only higher than this value. Okay, so if it is higher than this value, then we're going to go to the address of 11E1. So 11E1 is going to tell us that this is not a command, and this is not a valid command, so this is out of the switch statement. So what we're going to do is change our value. Okay, well, we don't need to change our value, we just need to understand how is working this switch statement. Okay, so we're going to compare it with 4. If the value is of 4, if the value is greater than 4, then we're going to jump and we're going to the L. We don't want this command is not specified here. Okay, but if that command is in the range of 0 and 4, then we're going to tell A, let's say we're going to tell that are going to change that register. Okay, so we modify and we tell it that I want 0. Okay, so it's going to make to make, how you say it, we're going to move the value at EV pointer minus 8, that is going to be 0, to the EDX. Okay, so let's move forward. This is going to get taken. The jump is not going to be taken, and then this jump is so important. What is happening here? EDX is storing the value 0, 1, 0, or 1, or 2, or 3, or 4, and it's going to be multiplied by 4. Why by 4? Because it's the int size. Okay, and then this is going to be added to this address 4011F2. So what is at 4011F2? Here, every address of the switch statement. So if it is 1, it's going to get multiplied by 4, and then it's going to be added to that address. So this is the jumps of the switch statement. So for example, if it is going to be 0, we are going to create a directory. If it is 1, we are going to copy that file, and if that file exists, then the operation is going to fail. Okay. If it is 2, in that case, it's going to delete that file. And if it is 3, we are going to create a key to the H local machine, and we are going to store some parameters. Kill access is going to, we have access to that key on that on this subkey, and the access is we have all access from that. And then we are going to store a value that is going to be pointed to the malware that is executed. Okay, so this is what is doing the malware. So the malware is first see if we have a connection. If that's not the case, if we have a connection, then it's going to make a request to this URA, and it's going to read the first 512 bytes that is in that file, and then it's going to read the 4 bytes that are in that file, and if they are a greater than sign, a question mark, and double dash, then it's going to read it's going to extract that command. Okay, and after that command, if we choose A, B, C, or D in this case, because we're extracting from the ASCII table, then we're going to get A, B, C, D, E, and depending of that values, we're going to create a directory or a copy a file or delete a file, or create a key on this key on the Windows register, and the last value is the program is going to sleep for like 10, I don't know, milliseconds, for 10 seconds, I think. So that is what the malware is doing. And if I'm mistaken, or if you say like you explain it so much, so terrible that I didn't understand, please let me know. But this is how you can get a grip of how you can disassemble malware. Okay, and this is just a taste. I hope that you fully understand what is going on, and if you have any questions, any doubts, please comment on the YouTube video. Thank you so much.